All right, now that you guys have gotten a chance to try this a little bit on your own, let's take a look at another one. So exercise 2, solve the system of equations algebraically using the substitution method. So first thing I'm noticing is I have two equations of lines. They both start with y equals. And we learned in the previous video that if they both are equal to y, they are both equal to each other. And this is something that I'm going to continue to harp on, is this idea of equality. What does the equal sign mean? So both of these have y equals and then some sort of expression, right? The expression is over here on the right side of the y equals. And what this means is if they're both equal to y, then they're both equal to each other. So what are we going to do to solve it? We're going to set them equal to each other. You're going to hear me say that a lot as well. Set them equal to each other. So here we go. Let's do that. We're going to start with the left one on the left-hand side. It doesn't matter. Equal sign is balanced, right? Both sides are the same, so it really doesn't matter which order you put them in. But I'm going to keep them in the same order that they're written in terms of each term. So the 3x goes in front and the negative 17 goes on the back. It's good to remind ourselves of these little things in algebra. We're getting back to algebra and not just graphing. Okay. All right. So we are going to solve this system of equations by solving this it's going to be more than two steps. We're going to get it into a two-step, but it's a one variable equation. All I have left is my x's. Okay, so the first thing I'm going to do is draw my line, and then I'm going to decide, okay, I have variables on both sides. I have the 3x on the left side, negative 2x on the right side. I have to get rid of one of them. How am I going to get rid of one of them? Well, I'm going to add 2x to both sides. So I always get rid of the negative one if I can. All right, so I'm getting rid of that negative 2x, okay, by adding 2x to both sides. Remember, anything I do to one side, I have to do to the other. 3x's plus 2x's should give me 5x's. I'm just going to bring down the minus 17. Equal sign on the line. You guys probably remember me saying that from previous unit, right? And now we have it into what we call our two-step equation, meaning there are two more steps to solve this. This looks very similar to things that we did in unit 1. So we're going to continue here. First thing we're going to have to do is get rid of, we always get rid of the one that doesn't have the variable first when we start our two-step. So in the two-step process, we're getting rid of the one that doesn't have the variable. That's my minus 17. How would I get rid of that? I add 17. If I do it to one side, I have to do it to the other. So here I go. I'm doing it to both sides. Okay. These are opposites, so they cancel. All I have left over on this side is my 5x, so I'm bringing that down. I've got 5x on this side, equal sign on the line, adding these together, 17 and 8. What's that make? 25. Okay. Now I've done my first step of my two-step. Now my second step would be usually division, right? So it's usually divide. In this case, it's true as well because we're doing opposites. Anytime we're trying to get rid of an operation, we do the opposite. So this is 5 times x equals 25. The opposite of multiplying by 5 would be dividing by 5, right? So I'm putting my division symbols here, okay? And I'm dividing by 5 on both sides. Okay, dividing by 5, 5 divided by 5 we know is 1. So all I have left over on this left-hand side is x. Still have my equal sign on the line there. If I extended my line a little bit further, let's do that. Let's see if I can do that quickly. There we go. Okay, that looks better. Okay, and then 25 divided by 5 should be 5. So I found my x, okay, which is crucial. But remember, a solution to a system of equations is not just x equals something. It's an xy pair. It's an ordered pair. It's a point, right? Remember when we graphed, it was wherever they intersected, correct? So I have the x value. Now in order to find the y, I need to take one of these equations. Doesn't matter which one. Let's just take the first one. It doesn't have a negative out front, so it might be easier, but I don't know if it'll be easier. I'm going to rewrite it. So y equals 3x minus 17. And then I'm going to plug in, I found x to be 5. I'm going to put a 5 in for x, and I'm going to simplify. And when I simplify, I should be able to get what y equals. So I'm going to put my parentheses pocket. Inside, I'm putting a 5. And I'm simplifying using my order of operations. First thing I see here is multiplication because that happens before subtraction. Okay, so 3 times 5 is 15. Okay, and then I have this subtraction here. You might want to check in your calculator just in case. It is not positive 2 because I'm taking away a bigger number. It's actually negative 2. All right, so I have just found both my x and my y. So in order to put that all together to find the solution, I put it as an xy pair, meaning I put it as a point. And this is the answer to this system of equations. This is the point at which these two lines would cross. Okay. All right, you guys are going to get a chance, more time to practice this stuff, and I'll see you in the next video.